Hi everyone, action time. Today what I'm gonna do with you, grade 12 physics 1-1. What is number 1? Past paper 1 and another one for question 1. So every video just we are gonna try to answer one question with you. Today question 1, multiple choice questions from 1.1 to 1.10. 20 marks total. Please try first and then you can correct your answers and then you can just count your mark. Please let me know on comment just what you are getting out of 20. So question 1.1, and from video link you can get PDF format of questions. Also you can try, or just you can pause video and you can try, but please try first. You are going to learn by trying. If you don't try, just see questions, watch video. No, doesn't help. Will help, but not 100%. To get full mark, please try first. All right, I think that's enough. So question 1.1. Let's start with forces. They're asking you about types of forces. Perpendicular force, okay, perpendicular to surface. So which one of the following forces is defined by this statement? So which force? Normal force, resultant force, frictional force, or gravitational force? Which one always perpendicular? So this is our question 1.1. Answer is A. Why A? Because check all forces. Friction force, for example, just let's eliminate all forces. Let's start with friction force. Friction force, opposite direction of motion and parallel to surface, not perpendicular. Friction force is gone. And gravitation force always going down, so not always perpendicular to surface. As you see, first diagram, force diagram, it is perpendicular to the surface, it's fine. But when you go to inclined system, just going down, not perpendicular, with another angle. So gravitational force also gone. And then apply force or resultant force, it means F net, depends on apply force and other forces. So resultant force sometimes perpendicular, sometimes parallel, sometimes with another angle. So not always perpendicular, but normal force, always perpendicular. You see this diagram, perpendicular surface. When you come this side, also perpendicular to surface. Our answer is A for question 1.1. You are getting your 2 marks. So let's continue with next one, question 1.2. Now you have 2 balls with mass m and 2m drop from same height, okay? And then when they strike the ground, which one of the following physical quantities will be same? Okay, so we are looking for which quantity is same for these 2 balls. Let's see. Answer is, okay, answer is still coming. All right, let's explain first. So as you see, just formula, you remember formula, weight is equal to m times gravitational acceleration. As you see, weight depends on mass. If you just mass change, weight will be different. So if you have m, weight, let's say V1 is equal to mg, you can calculate with 9.8, it's fine. And then V2 is equal to 2mg. As you see, they are different, so weight will not be same. You have 2 objects with m and 2m, and from same height, just going to ground, let's say h for each, h, and we are looking for when they just touch the ground, strike the ground, so which one is same, which quantity is same. Velocity, as you see, velocity depends on acceleration. For now, you can say g times delta t because it's going down, so it is formula. And then g times delta t, because you see, it depends on gravitational acceleration. It's constant for Earth, and then time. As you see, you never see here mass. So velocity is okay, maybe that one. Okay, let's carry on. Momentum. Momentum depends on mass. As you see, if you have m, mv. If you have 2m, 2mv. So it is gone. And then kinetic energy depends on mass also. Kinetic energy, m and 2m. So getting different answer. Our answer is B, we can say. Our answer is B. Why? Because velocity, to get velocity, you don't need mass. Question 1.2, done. Another 2 marks, done. Let's continue with next one. This question about momentum. Okay, you have graph, momentum and time graph, and they're asking you, okay, which one following time interval, right, measured in seconds, okay. Magnitude of net force acting on the object is greatest. Okay, we are looking for force. Which one? Between 0 and 1 second, or 1 to 2 seconds, 2 to 3, 3 to 4. Which one getting higher, just which one greatest force? That's our question. So let's see our formula first. F net times delta T is equal to delta P. We know that. And from that formula, we can write force formula. Force equals delta P over delta T. And then we can calculate for each. So from 0 to 1, how can we get? Let's say F1. Okay, F1 is equal to F1 delta P for 1 second. What you have? 20. So 20 minus 0, because for 0 you have 0 here. These 2 points we are using. And time 1 minus 0. And then you are getting 20 newtons. This is our first one, F1. Okay, F1, using that, F1, let's say F1 is equal to 20 newtons from 0 to 10. We are looking for greatest one. So let's calculate next one, 1 to 2. F2, let's say, from 1 to 2 seconds. F2 is equal to delta P over delta T. So what we have now, for 2 seconds, we have 10, as you see. 10 minus what we have, 20, and 2 minus 1, and then you are getting 10 newtons. Negative means just opposite direction. It's fine. Directly you can say 10 newtons because we are looking for magnitude of net force. We are not busy with directions. So we have 10 newtons, but we are looking for greatest one. B already gone because 20 is more. And then 2 to 3, one more time, F3, let's say, F3 is equal to what we have for 3 seconds, negative 10 minus what we have, minus 10 over 3 minus 2. You are getting also 20 newtons, these two same. Let's check from 3 to 4. I think answer is here. 3 to 4, F4 we are looking for now. For 4 seconds, what we have? 20. P2, P final minus P initial, you can say. Okay, let's explain this also. Delta P, it means P final minus P initial, and T final minus T initial. P final equals, for 4 seconds, 20 minus 10. We are using like that because P initial is negative 20. And then T final, 4 minus 3, and getting 30 newtons. Yes. So from 3 to 4, we can say our answer is D. All right. So we carry on. Let's see correct answer. We just calculate all. Maybe you don't need to calculate. You can just say, as you see, you can just use this angle. As you see, just increase. So what formula always, just to make sure you can use that way. All right, 1.3 done. Another 2 marks done. Next question. This one, work and energy. A ball is dropped from a highest flow. Okay. The ball makes an elastic collision with flow at time t0. Okay. You have a ball. Let's draw and let's try to explain. You have a ball and it is coming down and hit the ball and flow, just coming back. Okay, this one is happening now. Let's see what they ask. Which one of the following graphs shows how the total mechanical energy? Okay, total mechanical energy graph. Total mechanical energy. So if object is going down, what kind of energy transfer happening? Potential energy, E potential, transfer to E kinetic, right? Let's say we have 100 joules potential energy, and then kinetic energy, let's say, because there's a drop, so kinetic energy is equal to 0 from initial. And then final kinetic energy, let's say 100 joules transferred to all kinetic potential is equal to 0. Height is 0, so because of mgh, so you can say 0. But we are busy with mechanical energy. What was the mechanical energy? mechanical energy is total energy. For now, we have potential plus kinetic. So potential energy plus kinetic energy giving you mechanical energy is still same. 0 plus 100, mechanical energy for initial EM1 equals 100 joules. We are just using numbers, but it's fine just to understand. K plus EP is equal to 100 joules. As you see, from 0 to T0 time, first time when just hit the ground, and then from T0 to final one, still mechanical energy is same. So mechanical energy is constant. All right. So, and then we can see also conservation of mechanical energy definition. Sometimes they're asking you that conservation of mechanical energy states the total mechanical energy in an isolated system remains constant. Because of that, our answer is B. Question 1.4, done. Let's continue with next question. Let's see what is the next question. This question about spectrum. Two spectrum diagrams below. As you see, diagram 1, diagram 2, from blue to red. Diagram 2, let's see what which one of the following can be deducted from spectra. So the star is moving towards the Earth. If it is coming closer, you don't see like that. Star is at rest. If it is at rest, you're supposed to see same lines. Start moving away from Earth. Yes, this is correct. And both stars and Earth move towards each other. No, they don't towards each other. They are not coming to each other. Just they are going away from each other. When you go to that topic, we can just get more details. For now, our answer is C for 1.5. Let's continue with next question. Electrostatics. Okay, so question 1, too many different topics. Electrostatics now. The diagram below shows the field lines, okay, for electric field, and P and Q with different charge, asking you which one of the combinations below correctly shows the polarity of P and Q, positive or negative for P and Q. So we have to remember direction of electric field. Direction of electric field from positive to negative. Direction of electric field from positive to negative. Because of that, our answer is B. Why? Because P is positive. How we know? Because direction of electric field from positive to negative. Q is negative. Let's check options. P negative, no. And then B, option B says P negative, no. Option C says P positive, yes, but Q also positive, no, but positive for P and negative for Q. Just we should remember direction of magnetic field from positive to negative. Sometimes they're asking you draw direction of magnetic field lines. Sometimes just giving you just like this question. They are going to ask you polarity. This is our question 1.6. Answer is D. All right, let's continue with next question. Okay, another electrostatics question. Two identical spheres P and Q, okay, carrying charges positive Q and negative Q. Okay, let's draw our diagram. So we have positive Q, another one negative 2Q, and this one is P object and object Q. Okay, electrostatic force between these two, how can we calculate? Using Coulomb's law to calculate. So they have same magnitude of electrostatic force using same formula. For example, let's say F P Q. Because of P, just let's say this is F P Q, and then this is F Q P. What's the difference between these two? Only directions. Okay, because using same formula, K Q1 times Q2 over R square, or you can say QP, QQ is fine. K is constant number. Q1 is equal to plus Q. Q2 is equal to negative Q, but we don't have to just use 2Q. Negative, we don't need to use. Distance still same. As you see, distance between these two, they don't touch, still same. And you are getting K 2 Q square over R square. As you see, this is FPQ. When you want to calculate FQP, you are going to use exactly the same formula. Q1 times Q2 over R square, and then you carry on. K times Q1 is Q, Q2 is equal to 2Q, and R square, as you see, K times 2Q square over R square. As you see, you are getting same answer. If you want, you can give some numbers. For example, for each Q, 5 or 1, you can just calculate it if you want. But just know, if you have, even you don't need to calculate, but just to understand that I'm calculating it. So if you have two charges, if you don't touch magnitude of charges, if you don't touch distance, so you have same force, same electrostatic force between these two. Now we can see answer. As you see, our answer is B, because using Coulomb's law, Coulomb's formula, and getting same force. All right, now we are going to electric circuit. Identical, okay, let's see, resistors identical are all right. And internal resistance, we don't have, okay. Which voltmeter will have the highest reading when switch S is closed? So that's our question. What do you think? I think you have done already because we said try first. So our answer is V1. Why our answer is V1? Let's explain. Guys, first of all, when switch is closed, they said, okay, switch is closed now. First of all, we know V2, V3, V4, same voltage, because in parallel, we have same voltage. And then, if we say we have current here, we can carry on with numbers or just say IB, using Ohm's law, of course. If you have R is equal to V over I, so I is equal to V over R. So, we are looking for V voltage, so we can say V is equal to I times R. So whatever you need, you can use from Ohm's law. You can write three different formula. Now we are using voltage. So let's say, let's give numbers, or let's start with I. Okay, if you have I, what's your V1? V1 is equal to I times R. I think it's okay. But when you carry on with your conductor on the circuit, just carry on and come this side. When you come here, current sharing by these two resistors. So you have I over 2, and this side we have I over 2. So V2 is equal to I over 2 times R. As you see, half of V1. And V3 also same. V3 is equal to I over 2 times R. As you see, it is half. So you can just see from here. V4, when you come to V4, you have, yes, you have this way. Let's use current. When you just calculate this 2R, R over 2, you are getting right, because 1 over R plus 1 over R, 1 over R parallel, even you don't need this calculation, it's fine. Okay, 2 over R, and then R parallel is equal to R over 2. Now you have resistance, this combination, R over 2. When you calculate V4, I times R over 2. As you see, same as V2, V3, V4. So V2, V3, and V4, they are same, but V1 is higher than that. If you want to use numbers, if you are not okay with this, you can carry on with numbers. So let's say we have 10A, and the resistance, let's say, let's say 10 ohms. Okay, 10-10 method. Let's use 10-10. So you have 10 over 2 times 10, getting 50 volts. And then 10 times 10, 100 volts. As you see, 100 volts, 50 volts, 50 volts, 50 volts, you can calculate. Okay, too many things. But they are sharing current. What we should remember? We should remember just they are sharing current, parallel combinations, sharing current. That one is your keyword. Just getting answer from that. Answer is A, V1. Next one. Which one of the following electrical machines is electrical energy converted to mechanical energy? Electrical to mechanical energy. So generator, first option, AC generator. Guys, generator converts energy from mechanical to electrical, because generator, you are trying to make energy, you are trying to just get energy. So another one, DC generator also making mechanical to electrical energy, and then AC dynamo, just that one, not our answer. And our answer is what? DC motor. Our answer is D. Motor, just electrical, just with that machine. DC motor convert electrical energy to mechanical energy. 1.9, answer is D. Easy question. Huh? And next one, which one of the following combinations correctly links an emission spectrum and absorption spectrum, energy transition, electrons in atom? Okay, just we should remember something about this question. After that, easy for you. So energy levels you have, let's say E1 and E2. And then you have electron here. For E1, let's say from here, firstly it's going up, for example, electron just going up. If it is going up from low to high energy level, from low to high energy level, what's going on? First of all, just we should remember that. All right, maybe we can just show our energy levels and diagram, and then you are gonna get it. What's going on? Let's continue. This is our question. Emission spectrum, absorption. Let's see our diagram. Yes, energy levels here. So from lower to higher energy level, absorption as you see, and then from high to low energy level, just emission. Because of that, our answer is from high to low energy level, emission spectrum, and from low to high energy level, absorption. So that is our answer D. All right, 20 marks. Please let me know what you get out of 20. So that's our first video about this past paper. So we're gonna carry on with question 2 next lesson. Thanks. See you next lesson. I hope will help you. Good luck for your exam. So please let me know if you need any topic, and then we can just make another video for you. See you next lesson, everyone. Have a nice day.